All this time we were trying to know what is speed, what is average speed, which one is moving faster, who is moving slower and all. Now if I want to find out time, I need to measure a time. So in this slide we'll see how to measure time. Do you think this measuring of time happens only after the invention of the wall clock or the digital or the analog clocks came into existence? No. We were in a condition to measure time right from ancient ages. Okay? Have a look at this picture. What do you think it is? It's water. And the way the water flows down from one vessel to the other, we can estimate time. If you have a closer look at that picture, you will see that it has a scale, like you have it on the scale 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 centimeters. Similarly, there is a scale, water scale. So this is a water clock. Ah, you're familiar with this? It's sand clock. Sand falls from one compartment to the other, and time taken is measured in terms of how much time it takes for that sand to fall down. Sundial. This is a sundial. It's kept out in sun. See where the shadow is formed and accordingly try to measure time, whichever number it corresponds to. These all were used in ancient times across the globe, and these were all related to natural events which used to happen in definite interval of time. Again, a type of Indian water clock. We call it as Ghatika Patra. Okay, so at any moment, the small vessel inside this one would get filled with water and it would sink to the bottom, indicating, oh, it's the right time. Okay, now if I'm measuring time, okay, this is how I used to measure it in the olden scenarios. Now how should I measure time period, or what exactly is time period? Now I'm sure you would have studied this in your previous class, but just to revise it once again, have a look at this picture. What is this? It's a pendulum. Is it a simple pendulum? Yes, it's a simple pendulum. What is it showing? This is the support. Okay, I'm just highlighting it. This is the support bar. This is the length of the string of the pendulum, and this part is the bob. This is the bob. When I give it a swish, it's going to move. Initially, it is at position O. Then it will move. I push it from behind, so it will go to B. Okay. When it reaches B, it will come back to O via O to A and then via A to O. So see the transition, how that bob is going to move. That bob is going to start from O, go to B, come back to O, back to A and then to O. So the journey that the pendulum is going to take from moving from O to B to A to O is one oscillation. This is oscillatory motion. I hope you remember periodic or an oscillatory motion. Okay, so in this the pendulum is said to complete one oscillation when the bob starts from the mean position, that is O, and it moves to B, then to A, then to O. See the transition. From O to B, B to A to O. When this one cycle is complete, I say one oscillation is complete. So time period is time taken to complete one oscillation. How much time? Seconds, minutes, milliseconds. Depends. What will it depend upon? It will depend upon the length of the string to which that bob is attached. Now there was a very famous scientist, Galileo Galilei. Okay, what he did was he tried to find out what will be the time interval for one oscillation, and through various set of experiments what he found that was, for a given pendulum where the length of the string remains constant, whatever it is, 10 centimeters, 100 centimeters, 1000 centimeters, doesn't matter, that length is constant. If that length is constant, then the time taken will be the same to complete one oscillation. Which means if I take one pendulum, say pendulum A, whose length is 10 centimeters, I take another pendulum B, whose length is 10 centimeters. So if the length is same, the time taken by pendulum A will always be equal to time taken by pendulum B. Why? Because the length of the string is same. If I change the length of the string, then things will change. Time period will change. Who found this out? Galileo Galilei. Okay, and this observation led to the development of pendulum clocks. And the winding clocks and the wristwatches were a better version of nothing but the pendulum clocks. Nowadays, the clocks or the watches that we use, they have a small electric circuit inside them. Okay, and these clocks are called as quartz clock, and they are much more accurate than the ones which were used earlier. Now, I know what is ancient device. I know what is a time period. I want to measure time. What is the unit that I should use? As simple as it could be. The basic unit is seconds. Larger units could be minutes, hours. Go ahead, it could be years, 24. So if you see 60 seconds make 1 minute, 60 minutes make 1 hour, 24 hours will make a day, 365 days will make 1 year, 10 years will be a decade, 10 decades would be a century, 10 centuries would be 1 million, and so on. Okay, but whenever we use time for mathematical operations or to compute, we always refer it to the basic unit, which is seconds. After we know how to measure time in seconds, let's try and measure the speed. How to measure speed? I hope you remember the formula to measure speed. Yes, it is distance upon time, and I always refer to average speed, which is total distance upon total time. Is there any device through which I can measure speed? Yes, there is a device through which I can measure speed. Have a look at this. You will find it on the dashboard of your car, your scooters, your vehicles. It is divided into two segments. I want you to look at the picture very, very closely. See, I see a scale from 0 to 10, 20, 30, 40, right till 120 mph, miles per hour. And over here, 55550, 55,550. So do you think this 55,550 is the speed? No, it is not the speed. Let's try to find out what it is. When this arrow moves, when this arrow moves, whenever we start driving the vehicle, it is going to move. To say 40, 50, 60, 70, 80, you should not ideally cross 80 unless you are on a highway. This is speedometer. Speedometer. It is going to record speed, calculate speed of that vehicle in miles per hour. Okay. And so that is what the speedometer is going to do. But then what about the other version? Wait, let me tell you. This is odometer. Odometer, it's again a meter. It's again going to measure something. It's going to measure the distance traveled by that vehicle. So 55,550. This vehicle, which picture I have taken, has traveled these many kilometers. It is not traveling with the speed. This is not the speed. It is the distance in kilometers to what it has traveled. Okay. So now I want you to go back home and go downstairs, check your vehicles and try to find out speed and distance traveled through by referring the speedometer and the odometer.